It's not every day you see the names of Microsoft and Google on the same project. To top it off, we can also see that this new project, Featup, has also been collaborated with MIT, Berkeley, and equal contribution. If you ask in one line, this project improves the spatial resolution of any model's feature by 16 to 32 times without changing their semantics. And that is not a small feat, and we will see how shortly. Before that, look at this screen and then marvel at the examples which is happening. So this is all downstream improvement on the images without any retraining. Now, in order to understand this better, let me give you a short background. The thing is that deep features are a cornerstone of computer vision research, capturing image semantics and enabling the community to solve downstream tasks even in the zero or few shot regime. But these features often lack the spatial resolution to directly perform dense prediction tasks like segmentation and depth prediction because models aggressively pool information over large areas. That is where, when these researchers have introduced Featup, that is amazing because it is a task and model agnostic framework to restore lost spatial information in deep features. And they have introduced two variants of Featup, one that guides feature with high resolution signal in a single forward pass, and one that fits an implicit model to a single image to reconstruct features at any resolution. Both approaches use a multi-view consistency loss with deep analogies to nerves. Their feature retain their original semantics and can be swapped into existing applications to yield resolution and performance gains even without retraining. They also show that FeedUp significantly outperforms other feature unsampling and image super resolution approaches in class activation, map generation, transfer learning for segmentation, and depth prediction, and end-to-end training for semantic segmentation. If you look at this diagram on the top, this is the FeedUp training architecture. FeedUp learns to upsample features through a consistency loss on lower resolution views of a model's feature that arise from slight transformation of the input image. Before we go further, let me also show you a demo from Hugging Face. Let's restart this space because it seems to be inactive. Let's wait for it to come up. It is taking fair bit of time to start it on T4, so I think it's a free tier. So we will let it run. Meanwhile, let me take you to my Google Colab and we will try to get it installed and then see how it works. First up, let's change the runtime to T4 GPU and then I'm going to save it. Let's then git clone this repo Featup. So while it clones, so the thing which we are trying to do here, we are trying to load and work with catalog of pre-trained unsamplers that work with common vision backbones such as Clip, Dino version 2 and ResNet 50. So basically, Clip is contrastive language image pre-training, which is a neural network that can generate images from text description. Dino is deep interpolation network overlap, and then Dino V2 is improved version of Dino overlap, which is a type of neural network used for image recognition and generation. And then ResNet is residual network 50, that is a widely used network for image recognition tasks. Okay, so that is what we are going to do in a backbone. So you can see that our repo is downloaded. Let's import it, and I'm going to include another cell and then simply change the directory to it. That is done. And now let's install everything. And I have seen that this step takes around 4 to 5 minutes. So let's wait for it to finish and then we will proceed further because it installs a lot of things. Maybe let's quickly check. Okay, so this is still almost there, I guess. Okay, it is loading, thankfully. Let's wait for it to load fully. Okay, so you see it has loaded. So let me load one of the image from my local system and I am going to see how it works. I just uploaded a PNG image of this bear, and then I'm just going to go with Dino 16, and then we can just click on submit. And then on the right hand side, you can see it is working. There you go. Amazing, amazing. So this is a image we uploaded. This is the original, and this is the unsampled one. How good is that? You see, this is how unsampling works. Let me try another one. In this one, I'm going to give it a bit more complex one. This is an Australian outback with kangaroos and stuff. Let's go with ResNet. Click on submit. Amazing stuff. Amazing. You see the unsampling, how good it looks. And then you can let me try one more from my local system. I'm just going to go with maybe a Komodo dragon. Then let's try the clip one. There you go. How good is that on the right hand side? Amazing, amazing stuff. And then you can also select some of from their own. Maybe I'll just go with this one. And then when you click on submit, there you go. How good is that? Amazing stuff. And I will drop the link to this model card. From there you can easily access it, this demo, if you don't want to get it installed. So let's go here. It is still running, so let's wait for this one to finish. Took fair bit of time, and you can just simply restart this session. That is done. Now let's import this stuff. I hope that they have installed below, but let's check. So let's wait for it to finish importing. That is done, and now let's give it the sample image. We are just taking a picture of plant, and then we are composing it on transform. So let's wait. Okay, so what exactly is the error? Okay, I need to upload that one. It's already uploaded, but because it is the path is in this Featup, so I need to take that. The easiest way is to just go on the left hand side, click on this folder icon, and then if you just go here and then click on these three dots, copy the path, and then you can simply replace the path here. And now let's close it. Let's run it. That is done now. And now let's run our code with the Dino unsampler. So let me run it. And it has downloaded it. Let's wait for it. And there you go. So this is a image of plant, then this is original, and then this is the upsampled one. Amazing, amazing stuff. And then of course you can just replace that above image with any image of your choice here, and then play around with it. So really amazing stuff. I will drop the link to this amazing project in video's description. Let me know what do you think. If you like the content, please consider subscribing to the channel. If you're already subscribed, then please share it among your network, as it helps a lot. Thanks for watching.